All right. All right, I think I will get started. You'll probably have a couple more people popping in, but for those people in the audience, I'm very excited to introduce our highly anticipated IPSR speaker, Katy Milkman. Katy is a James G. Deanan Professor at the Wharton School at the University of Pennsylvania. Katy earned her undergraduate degree from Princeton University, where she studied operations research and American studies, and her PhD from Harvard University, where she studied computer science and business. Before I move on to all of her many accomplishments, I just wanted to say we're so happy to have you here with us today, Katy. Katy's research is centered on behavioral economics, from her early work on time and consistent preferences and mental accounting to her later work on nudges for good in both health and in savings. In Katy's work, you can find a rigorous array of methods ranging from lab experiments to audits, with a heavy focus on field experiments. She's worked with dozens of organizations. Maybe you guys have heard of Google, the US Department of Defense, the American Red Cross, etc. She has recently begun an exciting line of research on megastudies evaluating program and intervention effectiveness. What we all love about this line of work and about Katy's work more generally is the clear commitment to bettering science for everyone, to seeing what interventions truly work and pinpointing exactly why. Katy has been published in all of the top outlets. We're talking PNAS, OBHTP, Nature, Human Behavior, Management Science. It's just getting embarrassing for her now. The list goes on. When she's not adding to her endless list of research publications, she's hosting Charles Schwab's popular behavioral economics podcast, Choiceology, and she's co-directing the Behavior Change for Good initiative, of which she's also the co-founder. She's written for the Washington Post, the New York Times, The Economist, and penned a bestseller called How to Change the Science of Getting from Where You Are to Where You Want to Be. That's not the book in the back, but it's on the bookshelf somewhere. She's won too many awards to list, both for her research and for her teaching, and was named one of the world's top 50 management thinkers by Thinkers 50 in 2021. There's no question Katy is brilliant in her research endeavors, but I do want to take a moment to note one area in which she shines even brighter, and that's extremely important to me as a PhD student and to those of you as PhD students and collaborators in the audience. You often hear that you can tell what a person is truly like by observing how they treat those under them, those who have less power. I've only ever heard extremely positive things about Katy's from her students and from her collaborators. They say that she is a sensational mentor who always has your back and has your best interests at heart. She pulls for you like no one else. It's really rare to find this, and it makes her especially exceptional. Katy, your work is a staple in graduate courses on behavioral science. I remember reading your Hunger Games paper on temptation bundling for my comprehensive exams, and we just heard our first years buzzing about it the other day. We're so excited to get to hear and learn from you today. For our audience members, Katy has invited you to feel free to pop questions into the chat. I'll monitor and to interrupt for you. And then at the end, we'll have a Q&A where you can be promoted to panelists if you like to get to interface with Katy yourself. And Katy, the floor is yours.
Thank you, Sandy. And that was truly the nicest introduction imaginable. Dana warned me that you gave amazing introductions. Almost made me tear up. Thank you. And I'm super excited to share some slides and some research. So let's get going. See if I can make all the magic happen. Woohoo! Okay, and I'm gonna do one quick thing so I can see the chat on the side if anybody wants to interrupt. Okay. All right, I'm going to talk about a mega study approach to applied behavioral science. And I really do hope you will interrupt because this will be way more fun for all of us if you do. For this group, I doubt I needed to include this slide, but you always have to have the opening slide to set the stage. Who cares? Why is this important? And I think the reason that I am excited about the topic I'll be sharing today, the topic of mega studies and their potential to advance applied behavioral science, is in part because behavioral science, and I mean sort of not just economists who always have had influence, well, for as long as I've been alive anyway, have had influence in the halls of government. There's really been a big shift, and a broader swath of behavioral scientists are starting to influence policy in a serious way. And really that's happened in the last decade, thanks to the publication of the book Nudge by Cass Sunstein and Richard Thaler. Now there are literally hundreds of nudge units embedded inside of governments around the world, helping those governments make decisions about how to use applied behavioral science insights to improve their policymaking. I think it's really exciting. There's some debate about I-frame versus S-frame if anybody's following George Lowenstein and Nick Chater's latest paper. I'm happy to talk about that later too, but today I'm going to take as a given that this is mostly a good thing, acknowledging that there are limitations. And I'm going to talk a little bit about, though, if we are in favor of having behavioral scientists at the table and offering insights. How can we offer the best ones? So I think it's pretty agreed upon that policy advice should be ideally based on field experiments when possible. That's sort of the gold standard. Ideally, we start with an insight about human behavior. Maybe we start in the lab, but we do take it to the field before we start advising on policy decisions if we can, because then we can establish the external validity. But there's some problems with field experiments when we have an insight or an important problem, frankly, that needs an insight. One is that running them requires huge fixed costs, and it's really slow. It takes a long time for everybody in the audience who's done this. You'll be like nodding your head at home or in your office. And even when we do have field studies to look at, which isn't always the case, and when we're asked for policy advice, it can be really hard to make apples to oranges comparisons and come out feeling like we know what the best approach is. Let me give you kind of an example or a toy example to think about. Say you're being asked to give some guidance on what are the best ways to encourage retirement savings. You might look at lots of studies and say, oh, look, matching programs help when employers match. It helps to default people into retirement savings. You might find a bunch of different tools, social norms sometimes backfire actually, but sometimes help. So you might find a bunch of different studies showing different things that can be effective for encouraging retirement savings, but you'd be hard pressed to figure out, well, which is more cost effective or even in an absolute sense effective. And that's because, one randomized controlled trial is done with older women in Denmark and the other one's done with young men in California. And those are not apples to apples comparisons. So that becomes a challenge if you're thinking like, well, how do I offer guidance on best practice? And then, of course, a really big issue, particularly in behavioral science, but I think to some degree in economics, is that the replication crisis affects fieldwork too. And here's a shout out, by the way. I love the paper by, I know Stefano's actually at HBS today and Liz has moved to Harvard, but I still think of this as a classic Berkeley paper. This awesome paper they did where they were sort of looking at, how big is the effect size of nudges by looking at everything in the file drawer of a nudge unit. But generally, we don't have the file drawer to see like what field experiments were run, and we might have a misinterpretation or an incorrect expectation about what will work because of file drawer issues. We might not know what's robust and likely to be effective in a real policy setting. Okay, so what's the solution? Well, one solution, of course, is what Stefano and Liz did, but I'm going to talk about another. And PS is, I should really rephrase this question, not what is the solution, but like what is a solution? Because I'm not advocating for this to replace all other science, just to be a new tool in our toolbox. And what I'm really excited to share is an approach that I have been pioneering in collaboration, in particular with Angela Duckworth, but also with a team of about 150 scientists, including some of the folks who are participating here, which is trying to do a different kind of science, and we call it a megastudy. So what is a megastudy? A megastudy is a really big field experiment, but it's not just really big. Another feature of most megastudies, and certainly the ones that I have been most focused on running, is that many smaller sub-experiments are actually embedded inside of this large field experiment. They're all run synchronously with the same dependent variable. So taking you back to that retirement savings example, if you ran a megastudy and you were not sure, is it better to default people into savings or have a matching program, instead of just wondering about the Dutch and California samples and their non-comparability, if you ran a megastudy, you would literally run an experiment where you tested both simultaneously in the same population. So that's what I'm talking about, but normally we'd have many more tests than just two tools. We would test lots of ideas. So what are some of the benefits of doing science this way when it's feasible? PS, it's not always feasible, but I'm going to talk about some cases where it was. Well, the big one that I've been highlighting is it allows for comparability of results across studies, so very exciting feature. It also does mean that the fixed costs can be borne by a single central organizer, which lowers the marginal costs for individual scientists of entering. And I think that's really important. And if you think about some of the revolutions in the way we collect data, if you think about MTurk and the way it's lowered the barriers to entry of just going out and running a survey and collecting some data when you have a question, I would love to see us finding ways to lower the barriers to doing policy relevant research. And I think by having a centralized organizer that sets up these kinds of things and lowers the marginal cost, we can do that. I think another benefit is it can reduce risk when you set up a field experiment. And in our field, we still tend to value positive results more than null results, which we could debate how good that is. But anyway, that is the nature of the beast. And if we think, if I find it null, that's not as useful as something that I can go out and say, okay, policymakers, you wanted to know what would work. Here's an answer of something that's cost effective. If we test 20 things, it's more likely we'll come away with an insight than if we test one, right? So just like you want a balanced portfolio when you're investing in the stock market, it's nice to have a balanced portfolio of things you're testing, hypotheses you're testing, and also eliminates the file drawer problem in that, at least so far, we found that we can publish all our positive and null results together in a mega study, and that journals have an appetite for that, which is really lovely, that there's that opportunity to put it all out there, and in good journals too. Another benefit, we've been running these kinds of projects as tournaments, which invites more, I think, interdisciplinary contact than we'd usually have. Now, each of us has incentives to publish in our siloed journals, right? Maybe you prefer Quarterly Journal of Economics or Psych Science or, Journal of Applied Psychology, whatever is your favorite place. You could submit sort of a sub experiment into a mega study. You could still publish in your preferred journal because your little siloed study, it's still an island, but you will have run it in the context of this mega study, and you'll be exposed to the ideas of people in different fields who are running simultaneously. And so even if we can't necessarily literally get two teams to work together that have different points of view, at least they're rubbing elbows in the production of the mega study and seeing what others are thinking about. And this one I'll say is like the dog that hasn't barked yet. So I'm still excited about its potential, but I'm not going to share any results because I don't think we've gotten such exciting results to date, but maybe more will to come. In theory, when we have a really big big study with many treatments tested at once, it should be feasible to do more heterogeneity analysis and specifically, use machine learning techniques to find out not just what's the best treatment on average, but what works best for whom. Doctors like to call this behavioral phenotyping, and I work with behavioral economists in medicine so they've influenced the way I talk about this. This should, in principle, be feasible and more feasible in these kinds of wide experiments. We have not, I would say, gotten a lot out of this yet, but maybe to come. And finally, it speeds things up. If we can run 20 studies at once instead of one study at a time, obviously that accelerates the pace of learning. And that can be really important in a pressing policy situation where we have urgent needs. I am going to talk a little bit about some work we did to try to help with the pandemic response and the value that megastudies added there. Okay. I haven't done a lot of nodding to all the giants whose shoulders we're standing on, but I'll do a little nodding now. Not enough, but a little. This is not like out of the blue, of course, right? Megastudy builds on a long history in science of, many things. But one thing that I think it particularly takes inspiration from is the common task framework, which really revolutionized AI research about 15 years ago, roughly. And this was a change in the way that people who were developing algorithms sought to sort of solve problems. Say you're a researcher in image recognition, instead of figuring out, your own data set of images and running your algorithm on them and publishing about how well it works on your image bank with your criteria. The common task framework basically has led to every image recognition researcher agreeing they'll sort of work with the common set of images, a common image bank, a common data set, common criteria, sort of the same validation method on quality, and with full transparency of, how are we getting our results. And so that really accelerated progress because now everybody is really working on the same problem and getting comparable results. And of course, if you look at toy problems in, say, experimental economics, like the dictator game or the ultimatum game, there's a flavor of sort of common tasks being reused, but it's different in that there's not actual random assignment to different studies. So we don't have the exact same purity. I also think scientific tournaments have a similar flavor, but they don't tend to involve random assignment, which is interesting. So we're sort of trying to take the best of both worlds. Okay, so what I'm going to do in the rest of the talk is I'm actually going to talk about some mega studies that we've run. I'm going to share some data just to give you a sense of what we're up to. And let me just preview and say these are all now, actually, I'm only going to be presenting today published research. I'm like 2 weeks from having the next mega study data ready. So I'm sorry that everything is published, but we do have a bunch of projects in progress, new mega studies, one looking at savings outcomes, testing different techniques for encouraging people to put more in emergency savings. Another in partnership with Zern Math, which is a large platform that many teachers in high schools, elementary schools, and middle schools around the country use to get their students more proficient in math. We ran a big mega study to try to get students more engaged with that platform by communicating with their teachers in different ways. And actually, in the last week, we rolled out a mega study with a large pharmacy chain that'll look a bit like some of what I'm telling you now, but testing, I'd say, some more innovative ideas. So if you've been getting interesting text messages from your pharmacy encouraging you to get a COVID booster, it could be from us. Okay. So I'm going to start by talking about a model mega study, the very first one we did. So we made the most mistakes ever here, but I will mostly gloss over them. However, if you want to dig in, we'll talk about some of the lessons learned. This was done with 24 Hour Fitness, which is a 4 million member gym chain with 430 US locations. And I've already kind of given you an overview. This is an obvious talk outline, but I am going to go through the rationale for this one, methods, results, etc. And then I will tell you a little bit about our work on COVID vaccination, or actually it was on flu vaccination, to try to inform COVID vaccination campaigns. So you might say to yourself, okay, Katy, you and Angela decided it'd be cool to try doing mega studies. You thought this might be good for science. Like, why would you study physical activity as the first thing? Is that really the most pressing policy problem? And you would be right. But it does have some benefits. So first of all, let me point out, it is maybe a more pressing policy problem than you recognize. Only about half of Americans exercise sufficiently. And exercise is, as far as I can tell, the closest thing we've found to a miracle cure besides maybe sleep. Exercise and sleep are they're just amazing for you. The results, it's not a weight loss strategy. People mistakenly think it's a weight loss strategy. Instead, it's just good for your likelihood of getting every kind of bad disease and every kind of bad outcome. Another thing that I didn't know until I started doing some work on exercise is that almost 10% of premature mortality in the world is attributable to insufficient physical activity. So it's a big deal. Okay, but it's still probably not the most pressing policy problem. One of the things that leads us here is actually that it's a really nice place to measure high frequency decisions objectively. So I'd love to, maybe study eating or cigarette smoking, but guess what? I cannot get a good objective measure of those. And we were interested specifically in sort of repeated behavior change, durable behavior change, habits. This is a really nice place where you can study it. I sort of think of the gym as like the fruit fly of habit research. So we were interested in habits. We went to the gym. What did we test in this mega study? You may be wondering. Well, let me tell you how we got there first. There were 30 scientists in this first project. Our team has grown in leaps and bounds since, including, like I said, many of you. And we will keep growing for as long as we can sort of ingest more people and involve more people. So 30 scientists designed 20 different individually pre-registered studies. So each of these is an island. It's its own experiment like you'd normally publish in a journal, but then they're all pooled and launched simultaneously. And each has its own, theoretical motivation. I am not going to talk a lot about the theoretical motivations for the different things tested today, only because we just don't have time. But there's some individual papers that have been published about the individual studies where that is the focus, of course. We ended up with a total of 53 different experimental treatments in this study and one placebo control condition that I'll mention in a moment. And just to give you a sense of what happened when researchers designed, what we told them was here's your playground. Here are the parameters in which you can make changes so that participants will have different experiences. Researchers could vary the experience that participants had when they signed up for a digital exercise program. I'll show you some more details. So basically people go onto a website, it's very pretty looking, and they sign up for the program. And when they do, they take what is really just a Qualtrics survey, but it looks sort of like something else. It looks very pretty. And researchers could design what was in there. Researchers could design incentives people would receive based on their behaviors during the program, including whether they attended the gym. Researchers could design what reminders people receive by text and then also interactive text that could be sent up to 3 times a week, as well as weekly emails that were sent for the duration of the 28-day program. So that's the sandbox. And then we did insert, in addition to a placebo control condition where people basically signed up for the program and then were sent on their way without anything else. They were, encouraged to exercise more and told good luck. We also had I will call it best practices control condition. And what we did here is we took what we had seen from the literature to be effective in encouraging exercise. And we said, like, let's just put that in and see if researchers can beat it. So what had already been, we felt, established was that getting people to make a plan about the dates and times when they would work out, sending them reminders to exercise at those times, and then offering them small incentives, we call them micro incentives, in the form of points convertible for Amazon cash, seemed like it would be useful. The micro incentives in the study were valued at about 20 cents per gym visit. So every time you went to the gym, you could earn about 20 cents. All right. And then researchers, as I said, designed 30 scientists designed 53 other experimental conditions. And if I even just spent the rest of our time together, I could just talk about all the different interesting ideas people tested. And then we won't get into results, and I won't get to tell you about other things. So what I'm going to do instead is say there's a whole bunch of ideas that were tested. I'm going to call out some of the sort of winning ideas. If you want to read about every last one, they are all in our paper in Nature. But Sandy mentioned my work on temptation bundling. We did include a temptation bundling treatment where people got free audiobooks from audible.com and were taught about linking something fun with exercise as a way to make it feel less like a chore. We tested having people pledge to exercise a certain amount, sort of a type of commitment. We actually had real commitment devices. Some people made commitments on stick.com. We had different incentive schemes where people got paid for different types of things. So it was really quite a diverse set of ideas designed by economists, psychologists, and computer scientists. Okay, so how did the experiment actually work? So first of all, the study recruitment was a pain in the neck. We could get into I could spend a whole talk on that too. It lasted a lot longer than we expected, and we had a smaller turnout than we'd hoped. But this is often the case with field experiments. We recruited for almost a year. All 24-hour fitness members were encouraged to register for a program designed by scientists to create exercise habits. It was there was a website, stepupfitness.org, that they could go to on a phone or on a computer screen. And we recruited both with people. We literally hired marketers to go into the gyms. There were postcards and posters in the gyms. There were emails. There were app ads. So we kind of tried everything. The final sample in the study was about 63,000 participants. So pretty good. But honestly, we had hoped for a couple 100,000. That's how the cookie crumbles. They were more female than male. They were on average 40 years old with a wide degree of variation. And they'd been at the gym members for a bit longer than maybe would have been ideal from my perspective. I would have loved to sort of catch people at the beginning of their experience with the gym, but the average year since they joined with it were almost 4. Lots of Californians. This is a West Coast brand. And on average, people had gone to the gym about once in the last 4 weeks prior to enrolling. So, not a super representative sample, but it's who we got. Study registration worked as follows. You go to this website on your phone. For the most part, most people are doing it on their phone when they get to the gym, and they see this nicely designed website that, we hired a graphics designer to make it look professional, and they consent to be in a research study. That's what the terms and program conditions are. And then they give us their name, their email address, and their phone number. We validate that we can correctly send them text messages, and that's when random assignment happens. So they're randomly assigned conditions after they're validated. And of course, we at this point, we have the ability we've hooked them up to their gym account, so we'll be able to track their gym attendance, and everything's intent to treat. Okay, so we randomly assign them to different experimental conditions. Most of the experimental conditions earned repeated rewards for exercise, though some experimental conditions varied the reward scheme, but a lot of the repeated rewards looked something like this. You can earn points every time you work out. You get 100 points for registering, and you'll get roughly 20 cents a gym visit. Most programs had a planning component where you choose the days of the week when you intend to go, and you're going to get reminders at those times. A lot of A/B test content got inserted after these 2 screens, researchers showing people videos, giving them quizzes, encouraging them to behave in a certain way. And then people are congratulated, told they're all set, and that for the remaining 28 days of the program, they'll get interactive text messages and emails and earn points. And then they do indeed get reminders, reinforcement via both interactive texts, emails, and the text of the reminder, all of which were personalized to condition. So a researcher, just to give you an example, one researcher wanted to encourage people to choose workouts that they found fun in one condition, as opposed to workouts they found effective in another condition. This was eyelet fishbox treatment. And so her reinforcement is that when she's texting people a couple times a week, she'll ask them a question like, when you last made it to the gym, did you do an exercise that you most enjoyed? And if they said yes, they were encouraged to keep it up because that's the whole point of the treatment. If they said no, they were reminded, hey, you know, research shows that it's a really good idea to try to do things that are fun. And the emails similarly had some reinforcement components. Okay, so let's talk a little bit about results. And the first thing isn't really results. I'm sort of overselling this as a result. This is just a balance check, but that's important when you do an experiment. And it turned out, it took us a while to figure out, like, how do you do a balance check when you have a mega study with this many participants in it? So basically we did pairwise comparisons of all of the 54 study conditions, and then are just reporting the average, the total number of those tests that yielded significant paired comparisons at an alpha level of 0.05. And you'd expect it to be about 5% if things are balanced. And overall it was about 4% when we did paired comparisons on age, how long people had been members of the gym beforehand, average weekly gym visits in the 4 weeks pre-intervention, and their gender. So anyway, it looks like this all worked okay. Arthur is asking if there's any work on which recruitment methods are most effective. We did not experimentally study that, so I only have anecdotal evidence. Anecdotally, we got by far the best bang for our buck from email. And specifically, we had one email that was like dramatically more successful than the others, but again, not an A/B test. In hindsight, that was silly. If anyone wants to run this A/B test and publish this study, go for it. So the thing that seemed like it by far outperformed all the rest was we sent people what looked sort of like an evite and said, you're invited. You know, when you get that, like, and the little pops out a little card, and then it said, you know, we have this exclusive program for our members signed by world-class scientists that you can enroll in, you're invited. That was our best. So we sent that a few times after seeing it outperform all the other email attempts that we sent. But yeah, that hiring people to go in person to gyms was shockingly ineffective and very expensive. And the app didn't work that well either. All right, yet another not exciting result, because it's not really a result. I just want to show you what happened in the placebo control condition. So I didn't really describe exactly what happened, by the way, before. If you're in the placebo control, you complete all that information, you sign up for the program, and then the screen you see when you enroll just says, hey, congratulations, you've earned X hundred points for signing up. I don't remember the exact number, but we actually gave you points that were equal to the amount we expected others to earn to just equalize gift exchange. We thought that was a nice thing to control. And then we said, you know, good luck exercising. The program goes for 28 days. And they didn't hear from us again until the end when we said, like, the program is over. So it was an empty shell of a program. Honestly, you might say, like, oh, that might leave a bad taste in my mouth. I signed up for this thing and it did nothing. That was our placebo control. So that's our holdout, essentially. And this just shows you over time, in the 4 weeks before the experiment and the 4 weeks after, how many gym visits people in this group made. And what you can see, of course, is like there's some selection into the study. The people who choose to enroll in this, right, something was going on with them maybe in the week before they enrolled. They're like getting a little more jazzed about the gym. They want to keep it up. So they sign up for this program, and maybe they stay jazzed for another week and then sort of go back to normal. So anyway, this is going to be the group against which all other groups are compared in the majority of the analyses I present today. Okay, and then this is sort of like our big results graph. Yay, it's so exciting. This is a giant regression equation that I'm presenting to you, and I'm going to try to make sense of it. I do not want you to squint and try to read everything on the y-axis, but I guess you can if you really want to. But the x-axis is showing you a regression estimated treatment effect. So how many extra gym visits did each treatment, and there were 53, induce relative to that placebo control? And 0 is that placebo control, and that's the gray line. And then the dot, of course, is showing the point estimate. And then I've got 95% confidence interval whiskers. So what you can see visually decently is actually most of the point estimates are to the right of the placebo control. So that's great, right? That's exciting. Yay. Like most things didn't hurt people. Absolutely nothing hurt people significantly. They're mostly directionally positive. And then more importantly, 45% are significantly better than control. And you might be thinking, oh, but did you like, what's your p-value correction here? Like, that's a lot of multiple hypothesis testing. If you're thinking that, like, good, you should be thinking that. In our first mega study, which is what this was, we were sort of like agnostic and just said, here's all the standard errors, here's everything, you choose your preferred correction. Obviously 45% of things wouldn't be significant in a two-tailed test if nothing were working, but like pick your, we're going to be agnostic about confidence interval correction. In our later studies, we've actually gotten some statisticians involved who are taking a stand, and they prefer BH corrected p-values. So that is what we have started reporting in all of our studies since. But these are just uncorrected, and you can, take that with a grain of salt. You should. The other thing I want to highlight about this is how these new treatments performed compared to our sort of best practice control that we included in the study, and that was planning, reminders, and micro incentives to exercise. And that was a lot harder to beat. So that did pretty well. That significantly outperformed placebo control. Yay for replication. Hurrah. We're right that we knew something about what worked. And only 9% of treatments outperformed this arm at a significant level, which is, again, it's more than you'd expect by pure chance, but not a lot. So this was much harder to outperform, which is worth noting. So it was a tough bar. Okay. What I find most interesting, besides just the methods, of course, is like, oh, well, what wins? What comes to the top? And I should, of course, point out what wins has a few problems. Like, one is it doesn't significantly beat what's second, right? Like 1 and 2 and 3, they're indistinguishable. The other thing is the winner's curse. So I'm showing you a point estimate, but this one is not corrected for the winner's curse, which is that anything at the top or bottom of a distribution we know is like basically biased and needs to be corrected for inward. That's actually also something in our more recent studies that we are even reporting and like applying corrections, because those exist in the literature, but here it's just raw because this is how we started, gotten more sophisticated. But the raw best performer, which of course, if you were to pick of all the things we tested, what do we think is most promising and want to test further and probe deeper into, this is the best. And this is I think a really interesting treatment intervention. It was designed by John Bashirs of Harvard Business School. The insight behind it was we don't want to let people break the streak. So you've heard that term before. Like if somebody misses more than one planned gym visit in a row, that could be really bad. So how can we prevent people from doing that? Well, the strategy taken here was people were told that in addition to that very small incentive of 20 cents they would earn when they went to the gym, and of course it's described in points, not in cents, but it's still small potatoes, they could earn a whole extra 9 cents if they return to the gym after a missed visit, right? So say you had made a plan at the beginning, you said, I'll go on Mondays, Wednesdays, and Fridays, and then you missed your Monday workout. If you show up on Wednesday, now you could earn a whole 9 cents more. Whereas if you don't show up again until Friday, you miss out on that sort of gym bonus. So the goal is let's not have 2 missed workouts in a row, and we'll give you a small increase in incentive to communicate that even more strongly. Do I think the 9 cents is like the thing that's doing it? I do not. But I don't have proof, but I don't think 9 cents is enough to cover the gas for most people to get to the gym. Rather, what I think this is communicating is the idea and sort of the goal. It's directing attention towards like, don't have 2 misses in a row. We're trying to discourage that. And this treatment increased gym visits by 27% during the program. Okay, let's see what else I've got. And just this shows you like the data, what the data look like rather than what the intervention looked like. You might think, oh gosh, that's downward sloping. And it sure looks that way to my naked eye as well. For what it's worth, that's not significant. And we actually had 2 versions of this treatment in there, both of which were in the top 5 performers, and the other one isn't downward sloping. So I think that's noise. Another big winner, shocker, is just paying people more. There was one treatment in there that paid people almost $2 a workout instead of 20 cents, and that was successful. So incentives work. Interestingly, no more successful than the sort of clever reframing that encourages you to not to miss 2 in a row, but still. And this looks a little flatter. This is another creative idea that it was exciting to see work. So Bob Cialdini was really the lead on this, who I'm sure you all know his brilliant work on social norms. And he also has done work, as have folks at Stanford, showing that people, not only do we respond to learning what the majority of others are doing, but when we hear that a trend is on the rise, even if it's a minority, in fact, that can be really that can really want us to jump on the bandwagon. And so this treatment was actually a majority norm conveyed that was increasing. So like double whammy. People were told truthfully based on real data that Americans are exercising more before, and that message was reinforced throughout the intervention. And lo and behold, it led to a 24% increase in exercise. And that one looks increasing, but again, I think none of these slopes are significant. This one is basically a replication of the very first one I mentioned. We had two versions of it. We had offering you 9 cents if you missed a workout and came back, and then we had 16 cents. It's a long story why we did that. Anyway, they were both in the top performers, so it's sort of a replication within the study. And actually, I don't think we had any other sort of dual conditions that were the same, so that was nice to see. And then the final thing that sort of rose out that I wanted to flag is that one group, this was led by Barbara Mellers and Lyle Unger, two of my colleagues at Penn, and Juwan Kim, who is an assistant professor at Yale. They tested whether or not giving people the choice of whether they wanted their points that they could earn communicated to them either by saying, hey, you could earn all these points, or hey, if you don't go, you could lose all these points. So you could choose which of those is going to be more motivating for you. And that choice was an effective treatment. Okay, so 5 treatments that work the best that I wanted to highlight, and you can see the p-values for these are such that you can apply whatever correction you'd like, and they will, well, I'm sure there's some correction you could apply that they wouldn't survive, but any reasonable correction for multiple hypothesis testing. These seem to really be true results, which is exciting. And there's some others too, but going into more than 5 today seemed a little excessive. And we've done tons of robustness tests, so we can look at weekly gym visits instead of any weekly gym visits instead of average, which is sometimes an outcome in these kinds of studies. We have to sample weight our data a little bit to deal with unbalanced randomization. We can redo that. There were like some people who didn't get assigned to their intended condition. We can analyze the data either with the condition they ended up in, or the condition they were meant to be assigned to. It doesn't really matter. And we're looking into heterogeneity right now. And as I said, I'm not super impressed with the heterogeneity results, but I think it may be context dependent. Okay, so Dana, do you want to talk? Or
yeah, so I'm thinking about, commitment and consistency, the Cialdini-esque effect, or the Cialdini idea, and like what's happening. So I'm reminded of the commitment that I made, because I mean, obviously the few cents is, like you said, nominal. I'm just trying to understand, like, is it that I am, what's being made vivid for me? The fact that, like, you've commodified the idea of exercise to me, and that makes it feel more rewarding, and you've reminded me of how valuable it is, because somehow money primes value, and that makes me feel good about my health? Or is it like I'm reminded of the commitment that I made to myself? Like, what?
Yeah, like why is the planning reminders and
like it's just
working? Yeah, so I talked a little bit about some of these other things we layered on top of it, but I didn't get into that because it's a mix of things. So the reminder is salience, right? Like it's just bringing it to the top of the mind. I think Goldwitzer's done a great job with planning on highlighting like that is partly about making sure the action intention gap is closed with it is less likely that you'll forget. There's commitment and consistency, and the reminders reinforcing that. So I think all of that is going on. And then the micro incentives are a little sweetener. And I do think it's interesting that people respond to such trivial incentives, but we see it in other places too. I don't know if it's salience or if it's like every penny matters a little. Obviously, I showed you a result that like when we multiplied the amount we were rewarding them by a factor of 10, they did respond more. So they are sensitive to the size of the reward, but even the small one is enough to be something. We like rewards even in micro doses.
right. I mean, it just also, just thinking about some of Jeff Pfeffer and I can't remember his co-author's name, he's at UCLA. Why am I forgetting his name right now? Anyway, the commodification of time idea. So the idea that my time, time is money, and they talk about it in like a bad way. But in this case, maybe I'm reminded that I'm paying for a gym membership, or that my time is valuable, and that then makes me want to, utilize it well, or make the most of my gym membership, or
Yeah, that may well be that it's it's sort of drawing my attention to money and therefore making me think about the value of the membership.
yeah, maybe.
Or it may just be even a small reward is enough to matter in a context where you're intrinsically motivated. Obviously,
Right.
there's pay enough or don't pay at all research, but this is different in that these are really intrinsically motivated people to do this workout in the first place. They already have the gym membership. They're signing up for a program that they're hoping will like just engage them more. So I don't think we have to worry about crowd out for that reason. And I am seeing more chat, and I can only see, it only says Conrad to me, which is, I don't know, but I don't know if that person wants to come off mute too. You're welcome. Or I can read it. Okay, well, I'll read it. The other question, and I'm so sorry, I can't see the full names, probably something I'm doing wrong with my chat. Oh, there it is. Conrado. I was able to expand it. I'm learning even 2.5 years into the Zoom revolution. So Conrado, if I'm pronouncing that right, says, it sounds like a lot of the methods were based on external rewards, which is what Dana was just saying. Do I expect these to undermine their intrinsic motivation in the long run? In general, there is a literature in gym attendance that does not show crowd out, but actually crowd in. And what we find is similar. So I am focusing right now on the 4 weeks of the intervention, but when we extrapolate, or when we expand our scope of view and look further out, we see crowd in. There's about a 30% return in the long run to every extra gym visit we induce during the 4 weeks. So there are carryover effects in habit formation writ large, just like other studies that have been done of incentives in gym attendance. And I do think this is a special context where people are super intrinsically motivated, or else they wouldn't sign up. So I'm not sure it weighs, I don't know that we should think that means a lot in the intrinsic extrinsic motivation debate overall. Arthur, looks like.
Yeah, hi. So this is really important. I hope I can get involved in such a thing. I'm just wondering, Dana's question made me think of this. Do you sometimes able to include possible mediators in the analysis?
That's a great question. So one of the challenges of, I would say, in general field research is like we generally don't have great survey measures. In this case, because everyone had to register for the program, we did have an opportunity to collect some survey data, but it was very early, right? So it was like it was at the very start of this program, as opposed to in the middle where you might get a better mediator or later on. We do have interactive texting where some researchers tried to include things like links to surveys and questions that might serve as mediators. The response rate was abysmal, so the data is really spotty and it didn't end up being very useful to anyone. But in theory, that would be a wonderful thing to be able to do in a program like this. I will just say, like, that sort of didn't work out well for us, but it should be possible.
And I presume you also test these things for various moderators, demographic moderators.
Yes, we did. And that, in fact, is sort of one of the most, so there were not super consistent findings of moderators, but you wouldn't necessarily expect that because each study had its own theoretical motivation. And so there were some interesting moderators within some of the individual studies. But overall, we didn't see any patterns that really jumped out. Like some past studies have suggested, oh, these kinds of interventions are more useful for people who have lower baseline levels of physical activity. We didn't particularly find that. Or, that one gender or age group was particularly benefited. So there was a lot of heterogeneity. And there is ongoing work by machine learning experts playing with this data and trying to sort of figure out how much gain would you get by personalizing the intervention assignment as opposed to just assigning everyone to the first best treatment. Like, what can we squeeze out and how does that compare to prediction? So that work is ongoing. Rahul Ladhania, who's a professor at University of Michigan, is leading it. And so hopefully he'll have some papers out in the next couple of years that dig in interesting ways.
Great, thank you.
Yeah, thanks for the question. All right. So one thing that I've not really studied, although again, your amazing colleague Stefano Della Vigna has studied beautifully, so we're really building on a lot of his work. We thought would be interesting to look at was prediction accuracy, like to the extent that in advance, behavioral scientists, policymakers, et cetera, could have guessed how these treatments perform, that we don't need to run a study. We don't, if they could have guessed the best performer, the most promising intervention, and differentiated it from the least promising, then instead of testing 53 treatments, we could just test one. So one question is, can people tell what's going to work in advance? So we looked at this in a few different ways. We had a study involving prolific workers who were each making predictions. We had a study of professors recruited from the top 50 schools of public health, as rated by US News and World Report, who each made predictions. We didn't force these people to predict all 53 treatment arms. That frankly would just be cruel and unusual. We invited them to make as many basically as they were willing. And the average number on prolific was 17, and the average was 9 from public health professors. And then we also recruited some practitioners from behavioral science companies. So think Ideas 42 Behavioral Insights team. And so those are 3 different samples of predictors. The first thing I'm going to show you is prolific workers. There's a slight correlation. So on the x-axis is the actual treatment effect from a given treatment in our study, and the y-axis is the predicted treatment effect by prolific workers on average. You can see a slight positive correlation, marginally significant. One thing you might also notice is the axis labels are in really different scales. And that's because prolific workers were wildly over-optimistic about how well this would go. And then, Juliana, you're asking a great question. I'm gonna finish my prediction results, then I promise I will answer it. Public health professors were slightly less overly optimistic, but still dramatically miscalibrated on how well this would work. And they had absolutely no predictive power. In fact, they were negatively correlated with actual treatment effects, which is pretty fascinating. And then practitioners were the least well calibrated of all, though none of these are significantly different. Well, actually, this might be significantly different from prolific workers. They're almost marginally significant negative in terms of their predictive power, and the least overconfident. I'm just going to pool this all for you on this one slide, and then I'm going to get to your question, Juliana. The blue dots are, again, the estimated treatment effects of all the conditions. Those are the sort of real effects on the left of this graph. And then to the right, plotted right where they actually fell, are the average predicted changes for each treatment when we pool the 3 third-party predictor groups and we weight them equally. So we're equally weighting prolific workers, behavioral science practitioners, and public health experts. And what you can see is, there's 0 correlation and vast overconfidence in terms of the effectiveness. So Juliana, this is a great moment to say something about the I-frame, S-frame debate, because I am very sympathetic to the point that I think there's too much, we expect too much of I-frame interventions relative to what they deliver. I do think that's a big issue, and that is very clear in this data set. I think it's very clear in Stefano and Liz's data set as well. And I do think for big policy problems, I actually don't think there's anyone who would disagree. I've never met a behavioral scientist who would say, we don't need a carbon tax, we have social norms. So I think there's a false dichotomy in the paper, but I do strongly agree that we need system solutions for big problems and not an individual focus on behavior change to solve the world's most pressing problems. But I think there's a lot of contribution that those of us who focus on the individuals can make around the margins, and that they can be a nice complement to system change. And that's always how they've been discussed and used. So this paper is by George Lowenstein and Nick Chater, and I appreciate Juliana putting it in the chat. I actually really agree with what I think is their most fundamental point, which is it would be great if behavioral scientists thought about system change more, because we do focus mostly on individual change, and system change is needed to solve the great policy problems of our time. On the other hand, I think they set up an unnecessary or false dichotomy between individual and system change. I think we should pursue both kinds of research and both kinds of policy solutions, and they complement each other nicely. But I do think by setting up that false dichotomy, they got a lot more people talking about the paper. So it may have been a brilliant move to sort of spark controversy. Cool. Juliana, glad you agree. Anyway, I actually had a debate with George on stage last week at a conference about it, which was fun because I got to start by saying, George, there's no one I admire more in our field, and I hate this paper, but I only hate it because of the false dichotomy. I actually agree with most of the points. Okay. One more slide on how bad we are at prediction before I move on to some fresher data, although it's still kind of old data. It feels fresh. Scientists were also really bad at predicting if their own hypotheses would be supported. So this is a slightly different way of representing the data because we collected this differently before the study launched, but people predicted the % chance that their own intervention would yield a significant treatment effect. And then I'm showing you the estimated intervention effects, and you can see they're not correlated. we didn't know what would work. Okay, so let me conclude this bit, and then I'll tell you a little bit about some data on vaccination before wrapping up. So first big thing was like, yay, behavioral scientists could design interventions that significantly increased exercise that were very low cost. So that was good. We were very bad at predicting what would work, which suggests to me that megastudies really are valuable, because if we are basically throwing darts when we advise policymakers, then we need empirical evidence more, and we need to test more ideas to get to good results. Although I will say, of course, we knew sort of the best practice was good, but it was outperformed by 2/3 of the other treatments. Another thing, and I touched on this when people were asking about intrinsic versus extrinsic motivation, we did not do nearly as well at creating long-term change as we did at creating change during the 4-week intervention period. I don't think that's a shock, right? It's much harder to create durable change than short-term change. Only 8% of interventions individually produced change post-intervention that was still detectable. But in aggregate, we do see this sort of 30% carryover effect across all our treatments into the 10 weeks post. So we're seeing standard results for habit formation. Okay. So I want to tell you in our last 10 minutes, very briefly about what megastudies came next. And I mentioned at the beginning, there's a lot of ongoing work, but I think during the pandemic is when megastudies had a big opportunity to really shine and be of use to policymakers. I wish we had been able to do more. And I hope as other crises unfold, that other teams, and I hope ours too, will use this tool as a way to help inform policymakers about the best response. So we saw an opportunity for megastudies to be of value in the spring of 2020, when we all went on lockdown and started getting on Zoom like this for the first time. And we're thinking about, how are we going to get out of this? And it looked like the path out, and indeed the path out was going to be through vaccines. But we recognize as behavioral scientists, not everyone's going to line up and want a vaccine. There's going to be some who aren't super excited about it, or who need a little nudge. And obviously there were some who needed a big nudge, but we wanted to say, like, if we're going to communicate about vaccines, if we're going to encourage them, it'd be nice to have really good evidence for the best approach to take. So we put out a call to our team of scientists, and we teamed up with a couple of large partners. One was Walmart pharmacies, another was 2 large local health systems. I'll tell you about that in a minute. And we said, we are going to test messaging to encourage vaccination against the flu, a different respiratory disease, in the fall of 2020. But the whole goal of this project is to design interventions that we think will be portable and useful to encourage COVID vaccines when those become available. So the call to scientists was, design an intervention that we can test with the flu that you think will be useful against COVID. And then of course there's testing that followed to make sure that it did work with COVID. I actually didn't lead that, but I'll mention it. The good news, I will give away the punchline. You might worry, are these the same thing? The punchline is, thankfully, the things we tested did seem to be very useful for COVID as well. Okay, so the first mega study in this set was done with Penn Medicine and Geisinger, 2 large US health systems with millions of patients. And this project involved participants who were patients who had either a new or routine primary care appointment during the 2020-2021 flu season at Penn Medicine or Geisinger Health. And the patients in this experiment were randomly assigned to one of 20 study conditions dictated by what teams of scientists thought would be useful messaging to test. And people's conditions determine which, if any, text messages nudging them to accept a vaccine they would receive in the 3 days leading up to their appointment. And at the appointment, then the doctor was going to offer them a flu vaccine. And so our outcome is, do they get the flu vaccine when the doctor offers it to them? And the population we ended up with was about 50,000 patients, a little bit skewed female, a little older on average, fairly racially diverse. And in the prior year, 2019, 47% had received a flu shot, which is about the national average. The holdout group in our study was who, got business as usual treatment, meaning they still got reminder texts to come to their appointment, but there were no additional texts mentioning the flu vaccine. Those folks got a vaccine at a rate of 42%. And then the question is, how did the treatment stack up against that 42%? Again, I'm not going to tell you everything we tested, but we had, I should have said there's a business as usual control, and then 19 different text messaging strategies. Lots of creative ideas submitted by team scientists, ranging from sort of dedicate your flu shot to a loved one. You can text back the initials, just like you might dedicate a marathon run. My personal favorite was, here's a joke about the flu. Have you heard the one about the flu? Don't spread it around. Maybe that would be like sticky and people would remember, and then they'd think about getting a flu shot and they'd laugh, lighthearted. One test was protect other people, right? Do it for others, not for yourself. Another group tried to leverage sort of endowment effect default messaging and saying that a shot has been reserved for you. So it belongs to you. You don't want someone else to get your shot. Okay, so how did this work? Okay, so the usual care condition, as I mentioned, is about 42% vaccinated. Now I'm going to show you, just like I did with the gym treatment, what was the regression estimated impact of the different messages. And I'm not showing you every single one on the y-axis to prevent dizziness. Instead, I'm sort of highlighting a few. The best performer in this experiment led to about a 10% increase in vaccination, and it said a flu vaccine has been reserved for you. On average, the messages significantly improved vaccination rates. All three of the top performers used the reserve for you language, and none of the rest did, which I thought was interesting. And the joke about the flu, which is my favorite, that was a total dud. Bummer. This is the best performing was sort of very, very formal language, just what you'd expect to get from your doctor using that reserve for you language. So one message 72 hours before the appointment and one 24 hours before. At Walmart, we tested slightly different things because it's a different decision we're trying to influence. Not do you say yes when your doctor offers you a vaccine, but instead, will you hop in your car or walk to the pharmacy and request a vaccine? Slightly different choice. So different things tested. Here, the participants, not my ideal sample in some respects, in that they had all gotten a flu shot at Walmart previously, but that was a legal issue. You are not allowed to market about to people over text message, but if they had previously gotten this product, it could be called medical advice as opposed to marketing. So anyway, challenges with megastudies. The patients were randomly assigned to one of 23 conditions here, and this determined what messages they got from Walmart on September 25th and for up to 3 days after in 2020 about getting a flu vaccine. And this study was much bigger and really well powered. So we had about 700,000 people in it, and their vaccination rate in the holdout control group was about 30%. Okay, what did we test here? Again, we test, do you want to pre-commit to getting a flu shot? Do it to protect family and friends. We said a shot is waiting for you was one of the things we tested. We weren't allowed to use reserve for you language because they were worried about stockouts. This was a very close analog. And what we found is that waiting for you message that was repeated 2 reminders, one the first day and 3 days later, again, rose to the top. And I believe 3 of the top 4 performing messages used that language and none of the rest did. And commitment was good. More Americans are getting flu shots than in the past. That's just like that Cialdini rising social norm did pretty well too. Everything outperformed the control, and these were significantly different from one another. So there's significant heterogeneity across them, which is neat. Although a lot of that can be explained by multiple messages, which is also a thing that rose to the top. So sending multiple messages to people is very important. So nagging works. So here's the top performing intervention. Really simple stuff. Formality outperformed informality, which I think agrees with some research that Liz Linos was presenting at SJDM recently. Okay, key takeaways from this work. Reminders emphasizing that a vaccine is reserved for you or waiting for you. They outperformed others everywhere we ran tests. We also, when we sort of tried to in aggregate analyzed this data, we saw that congruence with the kinds of messages that people expect to receive, as opposed to informal, surprising, and interactive texts, worked much better, and multiple days worked better. Here are the predictions were also better, maybe because it's a simpler thing to predict, though still not great. Scientists still couldn't predict performance very well, but prolific workers were quite well correlated with the performance of the actual treatments. And the one thing they weren't good at was sort of like picking out the best performer. So they were correlated on average, but the top performing message was actually ranked 15th on average by forecasters. So they wouldn't have picked out what they should advise policymakers to do very well. And to the extent that you're interested, like, did this actually work with COVID? Because that was the whole point of the project, was to say, we'd like to be able to offer good advice about how we would deal with messaging communication when the COVID vaccine rolls out. Heng-Chen Dai, my former student and collaborator on both of these projects, did a beautiful paper that came out in Nature with Sylvia Sicardo as the other lead, where they showed that indeed text message reminders to get a vaccine were effective, and reminders that used ownership language, like the waiting for you, reserved for you, claim your vaccine, they were better than others. And there was another replication that I really love, an extension by Mitesh Patel, another collaborator on the original project. He's a chief behavioral scientist at Ascension Hospitals. And when their hospital system mandated vaccination, which PS, that's an S-frame intervention a la George. Great that was done. I was advocating for that. And they also layered on a text nudge in addition to their S-frame solution, and found that significantly accelerated it. And they told people that the vaccine had been reserved for you, the workers of the hospital who were mandated to get vaccines, and that accelerated their vaccination project. So that was really exciting, and a nice example of the complementarity between nudges and system change. Okay, so let me wrap up here, and then anyone who wants to hang out, I was told that there's sort of like chit chat after, but I'm going to end on time. Conclude, megastudies can, I hope I have convinced you, accelerate scientific discovery, allow us to compare apples to apples, so we can say, like, okay, here's our top recommendation. Maybe the top performer doesn't statistically outperform the second best, and that isn't, by the way, normally the case, but it's still our best bet at what a policymaker would want to roll out. It reduces the risks and fixed costs of doing field research. It can facilitate more interdisciplinary collaboration if we're all pooling our data together, and hopefully leads to policy recommendations that are better than we generate based on intuition. What I haven't said a lot about, and I think there's a lot to say about, is their limitations. There are many of them, and we could do a whole other hour together on that, but I will just highlight a few in closing. They're not perfect. We can't replace regular research with megastudies. They're really difficult to implement. They're complex. They have costly designs. They require huge sample sizes. So often, partner organizations wouldn't be able to do this. They require centralized coordination. And I talked about this a bit. The effects of top performing interventions are almost certainly overestimated due to the winner's curse. So that can lead to false optimism about what is going to work in the field and how well. Okay, so I just want to thank our awesome funders and staff. This took an army, and also all my collaborators who were on the first slide. And let me stop there and say I'd be super excited to chat with anyone who wants to stick around. Thanks for letting me tell you about megastudies. I know there's some folks at Berkeley cooking up megastudies right now, and I hope to see lots more of this happening in the wild. So yeah, happy to take questions. Thanks for listening.
Don, do you see your book prominently featured in Katy's background? Don's there. He just can't.
It's actually both of your books. Both of your books.
Yeah, both of them. One's on the top, one's on the bottom. Yes, he said. Yes, indeed.
Yeah.
I love your books.
I missed some of what was said because when they upgrade me to panelist, I lose a minute or two. But I just wanted, this is really exciting and important. I'm wondering, has anyone been able to do any sort of long-term study? In other words, if you want to look at, obviously, ideally something like survival, but even, whether a marriage will divorce or not, things like that.
With a megastudy?
Yes.
Oh my gosh, that would be so cool. To my knowledge, the megastudies that I just presented to you are among the only that have ever been done. So it's sort of a new approach. I am hoping there will be many more. And if you sort of look back in the literature, there are things that have this flavor. Like there's a wonderful, I call it the South African Bank study, and I don't remember who the lead author is. It's economists, so it's just alphabetical anyway, but like Dean Carlin and Zenil Mullainathan and John Zinman, looking at varying the interest rates they offered on loans and simultaneously varying lots of other things. In some ways that was a mega study because they tried a whole bunch of, it's sort of like a kitchen sink, and plenty of the nudge unit studies are to some degree mega studies, but they're normally not. What we're trying to promote is sort of like a tight hypothesis test embedded within a larger set of studies, as opposed to just we test lots of ideas simultaneously. And that is new, but it would be really neat to look at long-term outcomes. As far as we've gotten, we collected long-term outcomes in the gym, in that we looked up to a year out. But not surprisingly, given that our effect size is capped out around 27% increase during intervention, we're not seeing a lot of action a year later that's sustained.
Great, thank you.
Yeah. I would love to see mega studies that look at those kinds of long-term outcomes though.
Yeah.
What would you predict? So Art Aaron obviously is the god of research on relationships and law. What would you predict and do, Art?
Well, I mean, there have been several separate longitudinal studies, and we know a lot about what makes relationships likely to survive, but there's a lot of different ones, and it's hard to compare them, and people have new ideas, and it'd be great to be able to randomly assign couples to receive various interventions. That's been a big problem in the short run.
Would you use therapists to, like, you do different therapeutic interventions, or?
Now, I was thinking of more intervention, well, for example, with stuff that's been done with my research, is where you encourage people to do new, exciting things every week with their partner, or an intervention that's encouraging them to remember to be grateful in appropriate ways, or an intervention that teaches them about how to communicate during conflict, all those kinds of things.
Sorry, I didn't go away. I just pulled up my notepad because I wanted to write down what you were saying.
That's all.
And by the way, I'm sorry for not knowing I should call you Art instead of Arthur.
That's all right.
I love this. So you're giving me all sorts of ideas, which is why I grabbed my notepad and accidentally unplugged my camera. One of the projects that I'm super excited about that we're working on, that will hopefully be a mega study someday, right now we're in pilot phase, is we want to do group level interventions instead of, like, I think we've gotten quite good at sending text messages that change behavior, but not to insult anyone else who's like crazy passionate about text messages, but like I will be bored to death soon if that's the rest of my career. So we're starting to look at social interventions, and we're looking at college retention. We're trying as an outcome and seeing if we can build connections and community by putting students in groups and then encouraging different types of guided interaction. And we will be actually building on some of your work to try to build strong relationships in the first interaction. So thank you for the amazing research you've done on that. And anyway, you may get a follow-up email from me at some point about this. But so we're going to experiment with different things that can then be ingredients to see how we build those bonds downstream.
Studies that involve groups, like I'm just thinking about people in different gyms. I mean, theoretically, the analysis needs to take that into account. I don't know if it does. That complicates things.
It will. It absolutely will. Yeah. I think it's rich in neat ways in that, like, it does. So we have to have very large samples, and we have to cluster the standard errors and all that fun stuff.
Yeah.
But also there's like the neat aspect of who are you randomly assigned to a group with, and then how does that affect you? So I think there's like extra richness in addition to the overall treatment effect of whatever condition your group is assigned to. The features of the group itself can be another thing we study and how they affect you. So
yeah, great. Thank you.
Yeah, thank you for your work. We really literally are using your intervention materials in the pilots. So very excited about it.
Are there any more thoughts or questions? I mean, I think people are. So Jenny Chapman said, thanks, Katy. As you know, we hope to imitate your approach
Yes, I'm so excited that I think Jenny is starting to think about mega studies on culture, and I'm super excited to see where that goes. I obviously do not have the skill to do that kind of work, but really hope, we've learned a lot. We've made a lot of mistakes, I should say, which I mostly didn't highlight. And anyone who's interested in doing this sort of stuff, we would love to share what we've learned. And Angela and I recently wrote a PNAS Nexus piece that's just sort of like just explaining best practices as we see them to date. Obviously, this is kind of a new way of doing things, but that is somewhere on the web. And if anyone wants it, you can email me for a copy. But yeah, also happy to answer questions.
If no one has any questions, Katie, do you mind spending just 2 minutes telling us a little bit about some of the ways in which you brought to Washington to talk about how to do massive rollouts of some of your interventions on the COVID vaccine in particular?
Oh gosh. Well, I mean, in that case, I think our big takeaway was like, here's our best performer. Let's try that. Like, that was a really simple message from the mega study. And I do think that's what the mega study does best. In this case, there were no differential costs of the different treatments. We're running one right now, like it is literally in the field, and some of you could be in it. So but anyway, we're running an experiment right now with a large pharmacy and a rideshare company. And not only are we testing communication strategies, but also, a lot of investment was made in getting people free rides to vaccination sites. And PS, totally supportive of that. It seemed like a good idea. Let's throw everything we can at it, but it'd be nice to evaluate it and know if it works. So we are evaluating whether giving people free rides to and from vaccine sites is increasing booster take up relative to, say, just communicating that there's a vaccine reserve for you, or using other, we're testing some other things right now. But yeah, in terms of our first project, really the takeaway was, let's use this sort of ownership language. It seems to be very effective in concert with other things. Message.
What's your next frontier? So what do you, you addressed one of them.
The
college retention.
The work that I am most excited about, I think that there's a limitation of doing these kinds of interventions that are just, I change an email or a text message. They're cheap, they're easy to test, but we cap out on the amount we can really change lives. And I think there's an opportunity, especially for those of us who are like post tenure and have longer time horizons for our work, and I think there's big opportunity to build on the kind of work that Art has done, right? And try to figure out, like, how do we, the things that change people's lives, their relationships, their organizations where you form groups and bonds. Like, think about Alcoholics Anonymous, think about religion. Those are the things that, really pivot lives. And like, as social scientists, to the extent that we can better understand what are the ingredients that make the magic, so that we can build programs that help students stay in school, or help solve addiction even more effectively, then I think that's really exciting. So we're hoping to do more social and experiential work. We'll keep doing some text message studies because we're pretty good at that now, but I'm excited about the frontier being
social interaction.
Yeah.
That's going to be fun to get hundreds of thousands of people. And so once you figure that problem out, let us all know how you did it, because I can barely get 200.
Went very badly. So, as most pilots of ambitious things do, lots and lots of things went wrong. But we learned a ton, and I'm really excited. We're in a pilot again.
We're all excited to hear, because it takes me a year to get 200 people in a social interaction study. So I'm very excited to hear what sort of efficient methods you come up with. Sandy, do you have any questions or comments before we close up?
No, I just wanted to say I forgot to mention how incredible of a speaker you are. I was watching Rachel's talk yesterday on exercise habits, and like having like friends come and exercise with you. And I was literally thinking during that entire talk yesterday, like our field is like really, really inundated with all these different types. And you can say within a single study, but then you don't really ever compare effect sizes across studies. And I thought this was just like a perfect follow-up to that. And it's just like amazing work. Yeah. Really.
Thank you. And I love that project. Rachel's amazing. I should just give a shout out. Like I'm such a hanger on that project. She did such an incredible job. So, but thank you for the very kind words.